Good morning, one and all. I am Dr. A.GOPI, Associate Professor, CSE Honors, and my subject is Design and Analysis of Algorithms. Today I am starting about the topic of PRAM algorithms in CO1 syllabus. CO1 syllabus, we are having starting of the syllabus here. So this is our syllabus topics. Definition of an algorithm, algorithm specification, analysis of algorithm, CO1. PRAM algorithms, merging, sorting, string algorithms, the Navi string matching algorithm, Robin-Karp algorithm. These are the CO1 topics. In the CO1 topics, I am starting with that as a PRAM algorithms. That is my topic of today. So PRAM algorithms, what is the purpose of going to teach about that as a PRAM algorithm? So PRAM algorithm, it is a single processor communication. Single processor, whenever the 1970s, the systems are having of only single processor and the task is only one task able to perform the operation. So the single processor how able to matching with the number of things. That means a parallel machines how to working on the single processor. So that is one of the example is weather forecasting. In the weather forecasting, what happened after today and what will be having most probably analyzing the data and give the this much of analysis of will be there in the web forecasting. So weather forecasting is the major role of here at the time of 1970s and 80s. And that is the case, all the single processor is able to communicate with the multi-processing data of a shared memory. So the example of here, this is here multiple machines are working of a single task. So task 1, task 2, task 3, up to n number of processors are available of each and every one as a system. And all the systems are able to using of a global memory. So global memory means one single memory is able to task with the performance of a first task is stored into the global memory. Second task, second system is also say the data of a global memory. That means each and every time the task is divided into one of the system of a one task. Second system has a second task. Third system has a third task. Like that only we can divide the tasks, and those are the perform the analysis and final answer should be stored into the main memory. The major structure of here, the major structure of PRAM algorithm. So here it is a major system structure. Processor 1, processor 2, processor 3 is able to communicate with the memory access unit MAU, and this data is able to store in the shared memory. That means the main problem is dividing into, that is the main task is dividing into subtask. The subtask is able to performing of a system 1, system 2, system 3, system 4, system 5 up to n systems. Those are data should be stored into the memory access unit. That too is random to store in the shared memory. Suppose if the third task is performed very early, then that is stored into the shared memory in the third of this slot. And second system is the complete the task of the second processor, processor 2, then that is also shared into the second slot only. That is the case. This is the architecture of a single processor to store the data of a shared memory. Then coming to our structure of here, this is the way of representation. First task, second task, third task, fourth, fifth, sixth up to n. If the third task is completed very early, that the allocated third slot, it will be stored the data. So first task is the first position, second task is second position, third position, fourth position, like that. The data should be analyzed into shared memory, that is a global memory. Then only it is able to perform the task of here. So this is the structure of a PRAM algorithm. And the parallel computing is very similar to given as a normal way of representation. Any design, the single processor is able to give the multiple machines. The task of here, a problem is divided into many sub-problems, and each problem is given to as a one single processor system, and the output of the single processor system is able to stored into a main memory. That is also be as a shared memory only. So this is the process of a design for the multiprocessor machines to later on is executed of a parallel algorithm. That is the parallel algorithm. So coming to this as the normal way of representation. Normal way of representation. Right. So in the sorting algorithm, PRAM we are having two types of things are available. One is for merging and the one is for sorting. So sorting means already we know about the sorting, but what is the meaning of merging? Merging means the given two sorted sequences, the problem of merging into as a combined two sorted sequences into one single sorting sequence. So there are two different way of representations are there. Then the two things will be able to go for as a merging. That is how able to merging with using of a divide and conquer method. That is able to showing about that as our merging sort. So in the PRAM algorithm, the merging is dividing of a name of here odd and even merge. So in the odd and even merge, the algorithm is based on that as a odd and even merge only, and the conquering is here x1 is dividing of a x1 k1 comma k2 comma k3 comma k4 k5 like that. Now we want to make it as a division of odd and even one. So x1 is the one set, x2 is another set. So x2 is having of a k of m plus 1, k of m plus 2 up to k of 2m. So this is for as a k1 and this is for as a k2 or x2. So x1 and x2, these are the two sorted sequences are available. Then we want to make it as a processor to save the data as a merging 2m, where m is the integral power of 2. We can go through on that as a merging the process. So coming to this merging algorithm here, odd and even merge sort algorithm, step 0 step. Initialization of the step is m is equal to 1. Merge the sequence with one comparison. Sequence of the first comparison, we are able to go with the merge of the sequences. And step 1, x1 and x2 into their odd and even parts. So now we are having the x1 is a k1, k3, k5, k7 like that, k of m minus 1, and k1 even is having of a k2, k4, k6, k8, k10 like that up to km. These are the two partitions will be done by the step 1 itself only. Then we can move to step 2. The recursively merge of the x1 odd and x2 odd, both will be having up a x1 set 1 odd and set 2 odd, set 1 even, set 2 even, both will be as a merging the position of here. The level 1 is indicated that to x1 odd, x2 odd, x1 even, x2 even is able to using of a merge the data in the level 1. And coming to that as a step 3. Step 3 is indicated that shuffle of the data L1 and L2, then make a arrangement of which one is the least number, which one is the highest number, compare both the things and able to add in the sequential order, which one is the least one is the left side, highest value is on the right side. So that is the case, step 3 is involved here. Then now this is the one of the example of odd even merge. Now coming to this as a x1 is having of a data. So x1 we are having of the data is this is the data. Then x1 is equal to 2 comma 5 comma 8 comma some 11 comma 13 16 21 and 25. Then this is the data we are having, and x2 is equal to 4 12 18 23 27 31 34. So there are two sets are available in this position. X1 position odd number 2 comma 8 comma, the only position, don't go for as an values. So it is the even number, odd number, not like that. The position of here, first position, third position and fifth position like that. That means we are able to go with that as a x1 odd 2 comma 8 comma 13 comma 21. So that is the x1 odd. Then on x1 even, so 5 comma second position, fourth position, sixth position, eighth position, that is the x1 even. So these are the things to evaluation of that x1 odd and x1 even. Then same time same thing like as x2 also. In the x2 also we are able to go with that as a 4 comma 12 comma 23 comma 31 as a x2 odd, and x2 even 9 comma 16 comma 27 comma 34. So these are the x2 even, x2 odd. Now the main concept of here level 1, we are able to joining with that as a x1 odd, x2 odd here. Then the second one is the x1 even, x2 even. So those are the level 1 and level L1 and L2, where we take care about that as all the odd numbers of x1 and x2. L2 is represented as a x2 even, x1 even. So after this one, we are able to compare with that as a L1 and L2. 2 comma 5 we can add here, that is a 2 comma 5. 4 comma 9 we can add that as a 4 comma 5. Normal values to L1 L2 L1 L2 L1 L2 like that. So now after these comparisons only, we can go through as a which one is the least value, which one is the highest value, compare with the level of L, then compare them and exchange the values, which one is the least values and which one is the highest values. 2 is here only, 5 to 4 comparison, 4 is here, 5 is here. Now compare with the 8 and 9, 8 is here, 9 is here. That is the arrange the order of a sequential order. Now this is the final answer should be getting of a after merge the data. So these are the steps to involving of a merging. Next one is the sorting. This is one of the example of a students can do in the exam in the classroom itself. They have to complete that as a odd even merge algorithm using x1 and x2. That is the exercise of the students only. Then sorting. So PRAM algorithm, we are having a odd even sorting. So sorting means a sequence of n keys. The problem of sorting is to rearrange the given sequence either ascending or descending order. It may be ascending or descending. We have to using of a sorting technique. Then coming to this as an algorithm, step 0, if n less than equal to 1, step 0 is a n less than equal to 1 and written of x value, and step 1 we are able to go with that as a x value k1, k2, k3 up to kn. B is the input of the partition into, then this x is dividing into x1 and x2. So this is the one part of x1, this is the another part of x2 in the step 1 representation. Then move to step 3 and step 4. Step 2, allocation of n by 2 processors to sort x1 recursively of x1 the B result. Then x2 is also be same like that, only n by 2 processors to using of a x2 sorting the data. And step 3 is a merge the x1 and x2 using of a PRAM merge algorithm is n is equal to 2m processors. So merge the data of the step 3 only. Now going to as a example, so this is the x value, the number of values are available. This will be dividing into x1 data and x2 data. Then this x1 value is able to here, x2 value is able to here. And how they are dividing of x1 and x2 means they will split the data of a x1 and x2. Then after that, x1 is able to go for the sorting. Now we are given to using of a sorting the data. So using this as the sorting of the elements, and x2 is the sorting of elements, x1 is sorting of elements. Now in these positions we can take it as that as a odd numbers 5, 9, 12 positions only, 16. Then even numbers 7, 10, 15, 20, odd and even. And in the x2 also we can able to go with that as a odd numbers 8, 15, 25, 39. Then even numbers are 14, 21, 37, 42. Odd and evens are divided here. Then now it is the x1 odd, x1 even, x2 odd, x2 even. Again we are going to go with the level of here L1, x1 odd and x2 odd. That is the normal way of representation to take the x1 odd and x2 odd. Then L2 is represent that as a even of x1, even of x2. So up to this is that as a normal way of previous merging data only coming to here, and only one differentiation is here. The given data is a starting itself, we want to make it over that as a sort the data. Now shuffle the data is as usual normally, shuffling of the data. So 5 is there, then compare with that as a 5 to 7 is 7 is the highest number, 5 is the least number, and 7 to 8, 8 is the highest one. Then as usual we can go with that as a 8. Then 10 to 9 comparison, 9 should be as the here, that is a 10 as the next level. So like that we are able to using of a data to be in the sorting order comparison, and we make it over that as a all the data is in the order of representation. So this is the PRAM sorting algorithm, odd and even. Then next one is that as our normal simplification, differentiation of a merging and sorting. So differentiation of merging and sorting. So here the x1 and x2 are there, x1 odd, x1 even, x2 odd, x2 even, positions will be take care. Then L1 and L2 level, after that shuffle the data and increment order. And the sorting technique, it is first of all we have to use the sorting the elements, then as usual following of a merging the data, odd even, L1 is the x1 odd, x2 odd, L2 is the x1 even, x2 even. So shuffle the data and compare the data. This is the normal comparison about that as a PRAM odd, even, merging and sorting. So these are the two examples to give the students to complete the task of the what is the sorting of here and what is the merging of the data, odd even merge and odd even sorting technique. So this is the end of the topic of a PRAM algorithms. PRAM algorithms topic of a, so only for depends upon the odd even sorting, odd even merging. Thank you one and all.